Hello, I'm Trevor, one of the developers here for the TrashPanda app. This is the rest of my team, and here's my laptop, which is working fine right now, but there will come a time when it's no longer going to work and I have to dispose of it, and I want to do it properly. I'm in the camera feature of the app right now, and I've just taken a photo. I've opted in previously to sharing my location, so the app knows exactly where I am, and it's doing all the late work, and it's telling me to bring it to this Green Tree Recycling or Staples. That seems to make sense. So this is the vision that we had 2 months ago when development began on the project, to lower the cognitive tax of the user so much that proper recycling becomes effortless. As you've seen in the flow so far, it's accomplishing just that. You'll notice that a user takes the photo and they're told what to do. Also, after an image is taken, there's a symbol that's returned. In this case, it's a recycling symbol. That just tells me that I can put it in my neighborhood recycle bin. Also, trash and compost comes up. Sometimes none of those are the option, however. With the case of this paint, it's telling me to bring to this off-site facility. And so we provide contact information, hours, and phone numbers for each object class. An object class would just be like this toothpaste tube right here, and a disc you'll see. There's actually a little under 75 that we've been able to train our AI to recognize. Anyway, this disposal information is at the heart of the app, and it's provided by the Earth 911 API. Each category dataset extends nationwide, so users outside the US or those who decide not to opt in to giving their locations, they're still given general information, but not told exactly where to bring it. As you'll see, the image recognition isn't perfect, and this is actually a good time to show what the app functionality is like outside of just the camera feature. So initially, the UI team focused on a workflow based solely on this image recognition process, as we've seen so far, but they designed a fallback for when it fails, such as this search bar. So if the user knows exactly what they're looking for, they can just type it in. Alternatively, if they don't know exactly what it's called, or they just want to explore the app, they can use this click-through category search and just see what's there. So the image recognition as of now is only a few days old, and these other search methods were actually our primary methods for interacting with the app. It's pretty fun to explore. The UI team had designed it such that any category could be reached within 2 clicks, 3 at a max. Apart from making recycling easy, part of the vision of the Trash Panda was to improve recycling habits. Even avid recyclers might assume that this paper cup obviously belongs in the recycle bin. But if you explore a little, you might be a little surprised to find that they have linings that allow them to handle high temperatures, so it limits their recycling potential. Actually, right here, there's no results, so this would go in my trash, but this is a good time to demonstrate that I have dark mode, and if we go back, we know that raccoons come out at nighttime, so a little Easter egg. So plastic has been and still kind of is a huge pain for this app. For starters, there's so much variation in the material appearance that some categories of plastic return less than ideal results with the image recognition. And the category search used to be overwhelmingly large. It's because the API we're using contains all the numbers of all the plastic types, so that's what was displayed before. We opted instead for a workflow where the user would search for the material, then be prompted to look for a numbered stamp. This struck us as the optimal balance between the user's effort and prior recycling knowledge. It's actually a bit educational, so that's a tertiary goal. So the Trash Panda's usability and aesthetic was derived from surveys made with Google Forms and user testing in Zoom, preference testing in Usability Hub and wireframes, and prototypes in Figma. Trash Panda's web platform was built using Apollo Server, GraphQL, and Connects on the server side, and React, Apollo Client, and GraphQL through Parcel on the client side. The AI model was trained using SageMaker and deployed using Elastic Beanstalk and AWS. The dataset is about 15 gigabytes, and it was painstakingly created from downloading these raw images from Google and Bing and running them through our auto annotation pipeline that we created. These images were then vetted and adjusted manually when needed. Some already labeled data was taken from Google's open images, and that was kind of a blessing. But the biggest blessing was the team that I had to work with. So there's myself, Timothy, Tobias, and Vera. We were on the data science side. We spent the first half creating this wild annotation tool and debugging it as well, and the second half monotonously collecting and vetting the images. Lynn and Kendra, also known as Ken and Linda, depending on who you ask, they designed our beautiful app and shot down our terrible interface ideas. Then there's Mark A, Mark H, Colin, and Carlo, who learned all sorts of tech stacks to make this possible. And then there was John or Tim or JT, whatever he goes by, our project lead, and he was the one who kept us on track and all sane. Thank you.